Okay, this is section 1.2, Foundations Math and Pre-Calculus 10. We're going to do a quick review of powers in this section. It's something you should have worked on and learned through Math 8 and 9, but it's often a place where there's a few little misunderstandings, especially with negatives, and I think we should clear those up before we move on. I hope by the end of this lesson that you can write powers as repeated multiplication and vice versa. You can evaluate powers with and without a calculator. You can explain the difference between a negative power and a negative base, and that you can write expressions involving powers as repeated multiplication. So, check it out. Under ideal conditions, a single bacterium doubles in number every hour. If there are 10 bacteria to start, how many bacteria will there be after the following number of hours? So pause the video here and take a couple minutes to write out what you think will happen for these values. Hopefully you've taken a moment to go ahead and give it your best guess first. If we start with 10 bacteria and we double in number every hour, doubling would be multiplying by 2. So for 1 hour, we would have started with 10, and we would double it, giving us 20. For 2 hours, we would take the original 10, double it once, and then double it again. And that would give us 40 bacteria. For 4 hours, we'd start with the original 10 and double it 4 times. And that would give us 160 bacteria. For 10 hours, we have the original 10, and then we're going to double this 10 times. Now this is starting to get long to write out, so I'm going to take a shortcut here and say that there are 10 of these times 2's. And when we do that, we end up with 10,240 bacteria. And last but not least, 50, 10 times 2 times 2 times 2, and on and on and on. And this is a very large number. We won't calculate it. Oops. So you can see that these sections in here, where this repeated multiplication piece becomes very long and stretched out, it doesn't really make sense to be writing all of this out. So, is there a way that we can write these operations in a more compact way? And yes, of course there is. We use powers. Okay, so if we were going to write these same expressions with powers, 10 times 2 wouldn't really change. But a power represents repeated multiplication. So something like 2 times 2 can be written as 2 to the power of 2. And if we have 2 multiplying by itself 4 times, we can write that as 10 times 2 to the power of 4. And same thing here, 10 times 2 to the power of 10. So the 2 is multiplying by itself 10 times. And 2 to the power of 50 for the last one. For F, for n hours, n is just representing any number of hours. And for this one, we would have an expression of 10 times 2 to the power of n. So that's one use of powers. Anytime when there's repeated multiplication, we want to shrink it down. Here's an example of how that would work. And you often see this in scientific notation as well. Let's define a few terms that will help us talk about powers more effectively. So base is the value that's being multiplied by itself. So base, the value that is being multiplied by itself. The exponent is the number of times the base is multiplied by itself. And last, when we combine a base and an exponent, we get a power. And a power is an expression that represents repeated multiplication. So for example, if we had a number like 3 to the power of 5. 3 is the base. 5 is the exponent. And the combination of those two is a power. Now the way that we read powers changes a little bit, but most of the time we would read something like this, where you have 5 with an exponent of 4. We would say this is 5 to the power of 4. You might hear it said as the 4th power of 5. And that works for any value of the exponent. There are a couple cases where we sometimes do it a little bit differently, and that is when you have any value to the power of 2. We might read this one here, 5 to the power of 2, as 5 squared. And for the next one, 5 to the power of 3, we would read this possibly as 5 cubed. So those are just different ways. I could say it 5 to the power of 3 or 5 to the power of 2, but I might also say 5 squared or 5 cubed. If you turn over to the next page, for question number 9, you're asked to complete the following table. And you can see that I've given you a bunch of expressions. I'd like you to identify in each expression what the base is, what the exponent is, what it looks like using repeated multiplication, and then if you evaluate that, what do you get for a value? For question 10, I'd like you to do the same thing, but please be super careful on identifying what is the base and what is the exponent. Give it a try. Check your work after you're done.